Imagine a computer so powerful that it could solve problems which would take today's fastest supercomputers millions of years to complete. A machine that could revolutionize medicine, create new materials, unlock the mysteries of the universe, and maybe even break the very foundation of our digital security. This is not science fiction. This is the promise of quantum computing.
Quantum computers is the wild card. It could be a game changer. It could change the entire landscape of artificial intelligence.
But what exactly is a quantum computer? How does it work? And should we be excited or terrified about its future? Let's explore. What is a quantum computer? To understand quantum computers, we first need to understand how classical computers work. Every laptop, phone, and supercomputer today is built on bits, tiny electrical signals that are either 0 or 1. Everything from videos and apps to complex simulations boils down to billions of ones and zeros switching on and off. A quantum computer, however, doesn't just use bits, it uses something called qubits. Unlike a normal bit, which can only be 0 or 1, a qubit can be 0, 1, or both at the same time. This strange behavior is called superposition. Think of flipping a coin. Normally, it's either heads or tails, but while the coin is spinning in the air, it's kind of both at once. That's what a qubit is like. This may sound small, but it changes everything. Why do we need them? You might wonder, computers are already fast. Why do we need something new? The answer is that some problems are so complex that even our best supercomputers cannot solve them in a reasonable time. For example, simulating the behavior of molecules. This is crucial for drug discovery and materials science. But the number of possible interactions between atoms grows exponentially, so even the best computers struggle. Another example is climate modeling. Accurately predicting the long-term effects of climate change requires calculations so enormous that current machines simply can't do them. And then there's encryption. The security of the entire internet depends on problems that are very hard for classical computers to solve. But a sufficiently powerful quantum computer could crack these codes in minutes. In short, quantum computers are not about making Netflix faster or your games prettier. They're about solving problems that normal computers might never solve, no matter how advanced they get. How do quantum computers work? The magic of quantum computing comes from three main principles: superposition, entanglement, and interference. We've already talked about superposition, qubits being in multiple states at once. This means a quantum computer can explore many possibilities at the same time. The second principle is entanglement. When two qubits become entangled, their states are linked, even if they are far apart. If you change one, the other reacts instantly. Einstein called this spooky action at a distance. Entanglement lets quantum computers connect qubits in ways classical bits never could, multiplying their power. The third principle is interference. Quantum computers use interference to amplify the paths that lead to correct answers and cancel out the wrong ones. Imagine trying to solve a giant maze. A classical computer tries one path, then another, and another. A quantum computer explores all the paths at once, then interference makes the correct solution stand out. This is why quantum computers have the potential to be so powerful. If quantum computers are so amazing, why don't we already have them? Because building one is incredibly hard. Qubits are extremely fragile. The slightest noise, heat, or vibration can destroy their quantum state. This is called decoherence, and it makes calculations collapse before they're finished. So to protect them, most quantum computers must operate at temperatures near absolute zero, colder than outer space. They require complex cooling systems, isolation from the environment, and extremely precise engineering. Even then, qubits make lots of errors. Scientists are developing techniques called quantum error correction, but this requires huge numbers of qubits to stabilize just a few reliable ones. So while researchers have built quantum machines with dozens or even hundreds of qubits, we are still far away from the millions that may be needed for practical, world-changing applications. Who is building them? Despite the challenges, the race for quantum computing is intense. Big tech companies like Google, IBM, Microsoft, and Intel are all working on different approaches. Startups such as Rigetti, IonQ, and D-Wave are pushing the boundaries in creative ways. And governments across the world, from the United States to China and the European Union, are investing billions in quantum research, seeing it as a matter of technological leadership and even national security. In 2019, Google announced it had achieved quantum supremacy, demonstrating that its quantum computer solved a problem in 200 seconds that would take a supercomputer thousands of years to complete. While the result was mostly symbolic, it showed the world that practical quantum advantage is within reach.
What could they do for us? So what happens if we really crack quantum computing? Medicine and biology. Quantum simulations could allow us to design drugs far more effectively, leading to cures for diseases that today seem impossible to treat. Material science. They could help us discover new materials, from better superconductors to ultra-efficient batteries, changing energy, transport, and technology forever. Artificial intelligence. Quantum computing might supercharge AI, allowing models to be trained thousands of times faster, opening doors to entirely new kinds of intelligence. Finance and logistics. They could optimize complex systems, from financial markets to global shipping routes, saving time, money, and resources. But there's also a dark side. A powerful enough quantum computer could break the encryption that protects emails, bank accounts, and even state secrets. This could create a cybersecurity crisis unlike anything we've seen before. That's why researchers are also working on post-quantum cryptography, new ways to secure data against quantum attacks. The future. So should we be excited or worried? The truth is, both. Quantum computers are not replacements for classical computers. You won't have a quantum smartphone anytime soon. Instead, they are specialized tools, like particle accelerators or telescopes, designed to solve specific, incredibly hard problems. They aren't here yet, but progress is accelerating. What once seemed like science fiction is now a serious global effort. In the next decade, we may see the first real breakthroughs that prove their power in the real world. Conclusion. Quantum computers are more than just faster machines. They represent an entirely new way of thinking about information, based not on the rules of everyday life, but on the strange and beautiful laws of quantum physics. They may help us cure diseases, fight climate change, and unlock the deepest mysteries of reality. Or they may create new risks that we are not ready for. Either way, quantum computing is not just a technological revolution. It's a reminder that the universe is far stranger and far more powerful than we can imagine. So the real question is not if quantum computers will change our world, but when.